Welcome to another video using the particle model to explain the universe. Well, today's video is a little bit different. It's in an area of science I'm not that familiar with, and it's about carbon dioxide scattering and with possible new evidence for the particle model. I got an email from my friend Amnon Myers about an article in Nature Communications just published May 24th, 2019. And there's the link to it if you want to get it and read it. The title is Direct Dioxygen Evolution in Collisions of Carbon Dioxide with Surfaces. Yes, my friend Amnon Myers sent this news release to me and to my son David, and he stated in the email, "Hi, this seems to me to support the particle model." Amnon is one of our favorite subscribers, friends and subscribers. Well, here's an abstract of the experiment. The intramolecular conversion of CO2 to molecular oxygen is an exotic reaction, rarely observed even in extreme optical or electronic excitation means. I was going to look this up at this part, but I didn't get to it. Apparently, there are optical ways, sort of like hitting high energy light at CO2 and creating oxygen, or electronic excitation means maybe something like electrolysis. But here in this experiment, we show that the reaction occurs readily when CO2 ions scatter from solid surfaces in a two-step sequential collision process at hyperthermal incident energies. High energies, but with very little added heat. They don't add heat to it except to create the ion stream, CO2 ion stream. Anyway, that's their abstract. What got them started in this direction was that they found oxygen, too, in the coma of a comet. The coma is a nebulous halo around a comet that you can see as a comet goes by a star or our sun. It tends to get a glow around it, a halo around it. Excuse me. Although plentiful in modern Earth's atmosphere, molecular oxygen is extremely rare in space. Only trace amounts have ever been found in our solar system and in interstellar clouds. The recent discovery of abundant O2 in the coma of a comet, this is a particular comet, has rekindled interest in abiotic reactions. That's non-biological reactions occurring in extreme environments, which release O2 from compounds such as water, carbon dioxide, carbon monoxide, silicates, and metal oxides. So they found this in environments that they didn't expect it to happen, and in particular, it's not biological. Most oxygen is produced for us here on Earth, that the oxygen we breathe is a biological process. Okay, so I look for chemical equations. There should be a chemical equation for this conversion. The only one I found, not with an exhaustive research. There may be one out there, but I looked, seriously looked, but I didn't find one where it converted CO2 to oxygen. Most of them take something and ultimately get CO2 as a result as opposed to oxygen. Well, I stumbled on another article in the internet, and the title of this article is Plants Don't Convert CO2 into O2. This is a link to this one. It's a well-written document. I read the whole thing, and it's all about photosynthesis. And here's I say her, I don't know, I know a female biologist, so I don't know who the author is here. But the equation in the photosynthesis process is converting water to oxygen, including 4 electrons and 4 hydrogen ions. This statement is somewhat my own. In photosynthesis, light and CO2 are used to make sugars for plant growth and energetic electrons for splitting molecules. I'm saying, what, she states energetic electrons, and I picked up on that point. Whether my statement's true or not, I don't know. Well, let's look at CO2 for a minute. We're all familiar with dry ice made from carbon dioxide. And here's a typical graph that we're all familiar with. The one for water with its triple point is common, and CO2 has a triple point. Here's the gas, here's the liquid, solid, and they all meet at one place called the triple point, where you could go from gas to liquid or gas to solid, or the other way around. What's interesting about CO2 is as you get to higher pressures, this is pressure vertically, this is temperature horizontal. When you get to higher pressures and temperatures, you get to a state called supercritical fluid. Did not look into that at all. I can't answer one question about it, but it's interesting to note that it has a fluid state that has some special properties. Well, there are 2 other states for CO2. Carbonated water is a gas. We're drinking it. Huh? We swallow in those bubbles, and it's used in, actually it's used in a lot of food processing. I was amazed when I looked up CO2 on the internet and how many different times it's used for something. It's used to filter coffee. But you can have liquid CO2, and this is the only picture that I could find that I might make sense from. This is a tube of CO2 in which, you can't read this, I did, of course, is solid CO2 here, liquid CO2 up here, and it's capped in a tube because, as you can see, liquid CO2 needs pressure, and it needs a high temperature. So I don't know, maybe this is hot water. It's not clear to me what's going on here at all, except this is one example of liquid CO2. Okay, so back to the experiment, the article. The process involves previously unknown intermolecular reaction pathway, previously unknown, which occurs in energetic CO2 ion to surface collisions, with a surprising lack of dependence on either the nature of the surface or the surface temperature. The surface they use is gold, and we'll see that here in a moment. And what they're doing is they're shooting beams of CO2 at the gold. I had to relate to this because this is quite unusual apparatus. All experiments were carried out in custom-made, low-energy ion scattering apparatus. The CO2 ion, positive ion beam, was extracted from an inductively coupled plasma, struck in a reactor held at a pressure of 2 millitorrs, using a carbon dioxide argon neon gas mixture supplied with 500-watt RF power at frequency of 13.56 megahertz. Ions were delivered to a grounded the gold surface at 45-degree incident angle. Typical beam currents, how they measure this and do all that, I have no idea, of 5 to 15 microamps were spread over a spot, a 3 millimeter linear spot. The beam energy was varied between 40 and 200 electron volts by externally adjusting the plasma potential. Now, custom-made low-energy ion scattering apparatus, which apparently shoots out a beam of these carbon dioxide ions, much like an electron gun shoots out electrons. Well, here's the interesting chart. The CO2 hits a gold surface and scatters CO2. It scatters CO2 itself and its constituent parts, and it's mechanical. It's abiotic. It's physical mechanical. So let's look at the detail here. Here's the stream of carbon dioxide molecules coming at the surface at 45 degrees. They claim they got 100% of them here. What's interesting to note, at least at the start, is this molecule has very strong intermolecular bonding. The oxygen is bonded with a double bond. My general interpretation of that is it's a strong bond. In the particle model, the G2 gravity is what holds this together. And if this is matched well in terms of geometry and structure, then they can be physically close, and the closer they are, the tighter the G2 gravity is going to be in terms of holding them together. So 100% hit the skull surface, and they split into 4 different parts. 6% just bounce, the CO2 just bounces off, unchanged. 75% physically change to carbon monoxide and an oxygen atom. That's 73%, sorry. And then 16% actually totally split the whole carbon dioxide into a single oxygen, another single oxygen, and the carbon. The interesting one is the 5% that changed to a new structure. This is a linear structure. This is a triangular structure. Carbon and oxygens are held together through a single bond. Not so strong. They're further apart. I don't know if that's intentional. I'm just interpreting the drawing and concluding that it got changed to a structure that it can get to, but is further separated and therefore probably not held together as tightly. I don't even know how they know that happens, but there it is. They show it, and they not only apparently find a way to that they know this happens, but they then show that 51% of these, half of the 5%, turn to carbon monoxide and oxygen. 33% of them totally split apart, and 13% of the 5% actually turn into oxygen and a carbon atom. They mechanically hit the surface, and it splits apart, and it splits apart into its constituent parts. That is, some form of individual oxygen or carbon-oxygen atom molecules. Well, this reminds me of a particle accelerator smashing atoms to discover their structure. And yeah, if you follow this to the target, and what you're doing is you're blowing them apart. You're physically breaking the atoms apart to see what they are made of, mode of, type of finger problem. Anyway, we've been doing this for years, right? Smashing them to find out what they're made of, what the parts of each atom, each particle is. Uh, how successful we are at that is another subject, but it's another concept where you're shooting streams of particles or individual particles or enough particles to tear these things apart, just like this process where we're shooting the streams of CO2 and break them apart, not into their to find out what oxygen is made of, but the result seems to be just breaking them apart as if it were a chemical reaction. That's what happens in chemistry. We separate, drop sodium chloride in a beaker of water, and sodium and chlorine separate. Well, there are related TPM videos that are all mechanical and normally are explained chemically. A burning candle, fire, fast combustion is a chemical, you can get a chemical equation for that. I explained this in this video as mechanical. The wet cell battery is a chemical process, has an equation. I explain it mechanically. Electrolysis, using electricity through electrodes to stimulate some sort of reaction, can be shown to be a chemical type process, but I explain it mechanically. Cold fusion is very similar to is a special case in my understanding of electrolysis. So there are a lot of related articles where whether it's biological and a chemical reaction in biology, or it's a chemical reaction in the candle, the combustion, the battery, electrolysis. TPM explains it mechanically. Okay, the summary. This doesn't prove or disprove the particle model, but it could be supporting evidence for the fact that things can happen mechanically that we often think are biological or chemical. You can read the article. They have a chart which shows how they get this particular information. And watch my videos. That's easy. I did miss something that is very important, and I will back up. I apologize for this. There's a chart here which shows what products are developed and what the time delay. This is in femtoseconds. Femto is 10 to the minus 15th. Carbon monoxide and oxygen takes 16 femtoseconds. Carbon and oxygen take 43, presumably because it goes through this intermediate state. The total splitting either takes 14, which is probably this path, versus 45, which is this path. So there's in their paper, but this is why I'm mentioning it. If you read the paper, you will find that they have charts showing energy levels and timing as to when these things occur. Did not study it in detail, did not presenting it, but it would be interesting. You could find that information, those charts, the energies and the time in that paper. My name is Bob D. Hilster, and I am your particle model guru. Tune in next time when I'll explain more of the universe using the particle model. Thank you for your attention.